Hello, welcome to this video. In this video, let us take one more problem on dual cycle. Now, let us read the problem. The compression ratio for a single cylinder engine, so it is a single cylinder engine and operating on a dual cycle is 9. So, compression ratio is given, but the moment I see that it is a engine operating on dual cycle, okay, engine operating on dual cycle, what I would do is that I will write PV, TS diagram and then will also know the efficiency equation that is what we will first write. Okay. So, I know this PV, TS and efficiency equation for a dual cycle. So, that is what I will write first. Then compression ratio is what is given. I will write compression ratio is equal to compression ratio is given. So, compression ratio is 9. Okay. The maximum pressure in the cylinder is limited to 60 bar. Where do you think maximum pressure will occur? Maximum pressure in the cycle can be read from PV diagram. So, at PV diagram we can see that P3 is equal to P4, that is the maximum pressure and that is 60 bar. So, 60 into 10 power 5 Newton per meter square. Okay. 60 into 10 power 5 Newton per meter square. Then the pressure and temperature of air at the beginning of the cycle. At the beginning of the cycle means we are talking about P1 is equal to 1 bar. So, 1 into 10 power 5 Newton per meter square and T1 is 30 degrees Celsius. So, 30 plus 273. So, 303 Kelvin. Okay. Heat is added during constant pressure process up to 4% of the stroke. Now, heat is added between 3 and 4 in constant pressure. So, we can rewrite that like V4 minus V3 is equal to 4%, 4 by 100, 4 by 100 of the stroke. So, stroke is V1 minus V2. We know how to solve this. We can take V3 common here. If we take V3 common, it will be V4 by V3 minus 1. This will be 0.04. We can take V2 common here. This will be V1 by V2 minus 1. We can cancel out V3 and V2 because V3 is equal to V2 because V3 is equal to V2. Constant volume process between 2 and 3. So, then V4 by V3 is cutoff ratio rho minus 1. This will be 0.04. V1 by V2 is R. So, this will be R minus 1. Now, we know what is the value of R, 0.04, R is 9. So, 9 minus 1, this will be 8. Then we can find out the value of rho. So, rho minus 1 is equal to 0.04 into 8. Okay. Let us solve this. Alpha x minus 1 alpha equals 0.04 into 8. Now, we can shift solve for x is equal to 0, we will get 1.32. The value of rho is equal to 1.32. Most of the times, this is how the value of rho has to be calculated because it will be given that the constant pressure happens for some percentage of the stroke. Okay. Now, assuming the cylinder diameter and stroke length, assuming the diameter of the cylinder as 250 mm. So, 250 into 10 power minus 3 meter, that will be 0.25 meter and stroke length is 300 meter, 300 mm. So, 300 into 10 power minus 3 meter, again that can be 0.3 meter. Now, stroke length and diameter is given and we have been asked to calculate determine A stand efficiency. Now, we know that the compression ratio is known to us. We know the value of rho, we have calculated that. Now, the only unknown is we will have to get the value of beta. Okay. Once we get the value of beta, I think we will be able to calculate efficiency. Now, how do we calculate beta? Beta is P3 by P2, isn't it? Beta is P3 by P2. How can we calculate beta? 1 is by this method, P1 is given. I think P2 can be calculated. From there, we can get P3 is already there. Let us go for this process 1 to 2. Now we can use process 1 to 2. We have this pressure ratio. P1 V1 power gamma is equal to P2 V2 power gamma. And this is P1 V1 by V2 whole power gamma is equal to P2. Now P2 is equal to P1 R power gamma. So P1 is known to us 1 bar, so 1 into 10 power 5, and R is given to us 9, so 9 power 1.4. So we can readily calculate P2. So the value of P2 is 1 into 10 power 5 multiplied by 9 power 1.4. Okay. So 21.67 into 10 power 5 or 2.1, that is also fine. So 21.67 into 10 power 5 Newton per meter square. I have just kept it in 10 power 5 so that we can say it in bar, otherwise it is okay. Answer doesn't change. P2 is equal to 21.67 into 10 power 5 Newton per meter square. Now I think now we can go for beta. Beta is equal to P3 is given 60 bar. So 60 into 10 power 5 divided by 21.67 into 10 power 5. Now this 10 power 5 cancels out. We can have 60 by 21.67. 2.768 or 2.77 is good. 2.77. So beta also we have got. Now it is time to substitute it back to the efficiency equation and get the efficiency. Now efficiency is equal to 1 minus 1 by, now R is 9, 9 power gamma minus 1, gamma is 1.4 minus 1, so this will be 0.4, and beta is 2.77 multiplied by rho is 1.32 power 1.4 minus 1. This has to be multiplied by beta is 2.77 minus 1. I will write here 2.77 minus 1 plus beta again 2.77 into gamma is 1.4 into rho minus 1. So 1.32 minus. Okay. So this can be further simplified before we substitute it to calculator. 1 minus this 1 we can leave it. Okay. 2.77 into 1.32 or 1.4 minus 1. Okay. Then 9 power 0.4 into this 2.77 minus 1 is 1.77 plus this is again 2.77 into 1.4 into this will be 0.32. Now let us solve this equation. I will take the numerator first. 2.77 into 1.32 power 1.4 minus 1. So that is 3.08. So 1 minus this is 3.08. Let us take denominator 1 by 1. Maybe I will go for 9 power 0.4, 0.4, 2.40 or 2.408. So we can take 2.41, that is also fine, into 1.77 plus, so otherwise we will solve this in calculator. 1.77 plus 2.77 into 1.4 into 0.32. So that will be 3.01. Now I think we can solve this directly. We'll get 1 minus 3.08 divided by 2.41 into 3.01. 57, that is 0.5754. 0.5754. We'll have to multiply it by 100 to keep it in percentage. So 57.54 percentage. Okay. So for the given compression ratio, cutoff ratio and explosion ratio, we get if the cycle is operating in dual cycle, we get the efficiency as 57.54 percentage. Thank you.